Hello students, this is Mr. Void. In today's lesson we're going to look at evaluating algebraic expressions. Evaluate means to substitute a number in place of an equivalent variable and use the order of operations to find the value of the entire expression. Don't forget that the order of operations is P, which stands for grouping symbol, so we do that first. E is exponents, which includes powers and square roots. M and D is multiply or divide from left to right, and then of course you want to finish up by adding or subtracting from left to right. So here we're given 4 different expressions, and we're asked to evaluate each expression if A equals 3, B equals 5, and C equals -1. So here I see I've got the expression 6A minus 3B equals 8. First thing I want to do is substitute the equivalent number for the variable. So that means I'm going to have 6 times 3, substituting the 3 for the A, minus 3 times B, which is 5, plus 8. Now using the order of operations, I'm going to take care of all of my multiplication or division from left to right first. So this would be 18 minus 3 times 5 would be 15, plus 8. Next I'll add and subtract from left to right. Since I've got subtraction first, I'll do that first. 18 minus 15 would give me 3, plus 8. 3 plus 8 would give me 11. Okay. For our next example, we've got a to the second power, or sometimes we call it a squared, times b plus 2. Okay, so again, the first thing I need to do is substitute my numbers for my variables. So the 3 is equal to a, so I'm going to put 3 in place of the a. I'm going to put 5 in place of the b. And then I'm going to solve this. Okay, so I do my parentheses first. So my 5 plus 2 would come first. So I'm going to do 7. Parentheses means to multiply when they're right next to a value. 3 squared, I'm going to do that next because that's my exponent part of this problem. I'm going to do 9 times 7, and 9 times 7 would leave me with 63 for my final answer. Moving on to our third example, 3a minus 2b equals 3. So again, I'm going to substitute those values in. 3 times 3 minus 2 times 5 plus 3. Okay. And then of course we're going to do our multiplication first. So we'll have 9 minus 10. 2 times 5 is 10 plus 3. Again, we're going to do our addition and subtraction from left to right, so that's going to leave us -1 plus 3. Last, we'll do -1 plus 3, which will leave us with 2. Last example is a multiplication and division problem. But again, I'm going to substitute my values. So this would be 3 times 5 divided by 5. The fraction bar acts as a grouping symbol, so that I'm going to do the 3 times 5 first, and then divide by 5. And 15 divided by 5 is 3. Notice I never put an equal sign in any of these because these are not equations, guys. These are expressions. Okay? So now I want you to pause the video and explain in your own words how to evaluate expressions. Alright guys, moving on to representing real-world situations. So here we're going to be writing algebraic expressions from real-world problems. So the first one says, first example we have here is we want to write an expression for the total cost of gasoline when gasoline is $3 per gallon. Now the first thing we want to do always is identify the variable and what it represents. So I'm going to let G represent the number of gallons. So this problem, if I write the expression, would be 3G. $3 times the number of gallons would represent the cost of gasoline when gas is $3 a gallon. For example number 2, the total charge when a company has a $40 charge plus $11.50 an hour. So we're going to let H equal the number of hours. Now you can choose your variables to be whatever you want to, but it seems logical to me here to let G be the number of gallons of gas, and again H be the number of hours for this example. So when I write the total charge, I would start off with $40. That's a fixed charge. There's nothing that I'm multiplying that by. Plus, I've got $11.50 per hour times the number of hours would give me the total cost. One big hint is whenever we have $3 per gallon or $11 an hour, we could also, instead of an hour, we could write per. Big hint is that's usually what we're going to multiply our variable by. Okay? But you do have to use some logic in these problems too. So the number of packages when 65% of the packages are left. So let's see. This one I don't even think represents a variable. This would just be 65% times 300. So we don't even need a variable here because 65% of 300 would be how many packages. So we could say, we could make this one an equation where 0.65 times 300 is P, but we're asked to write an expression, so we're not going to throw that equal sign in there. Okay, let's move on to the next one. The amount of feed left, that's interesting, the amount of feed left when you have 15 pounds of chicken feed and you use, circle some key words here, 2 pounds per day. So if I'm using feed and I start with 15 pounds, so I'm going to have 15 pounds to start with, and I'm going to subtract 2 pounds per day. So let's let D equal the number of days that I actually feed these chickens. And so that would give me 15 minus 2D. Now let's just see if that plays out right. Let's say I fed the chickens for 2 days, so D equals 2. So that would be 15 minus 2 times, let's see, D is 2. So if I fed 2 pounds per day for 2 days, that would mean that I would use 4 pounds of chicken feed, which would leave me with 11 pounds in the container at the end of 2 days. Okay? So I see that we have some your turn problems. I'd like for you guys to pause the video and try those. They will probably be popping up in your video as quiz questions. Okay, guys, let's move on to the challenge problems here. I'm going to let you guys go ahead and do these challenge problems, and I'm going to put them in the video as a quiz. So guys, thanks for watching, and if you're on YouTube, click the subscribe button, and if you click the bell, you'll get notifications when I put out new videos. Thanks so much. Have a good day.